We're rolling.
Hello everybody, this is Gavin McCormack here and we are in the Arctic Ocean en route to the North Pole. I am very, very lucky today because I have Daniel here with me. Daniel, say hello.
Hi everybody.
Daniel is an environmental enthusiast and naturalist, which is amazing. He gets to spend his life outdoors. Now this week we're going to be talking all about climate and weather. Now here in the Arctic, temperatures can go down to -40. That is extremely cold. Now, I don't know everything about weather and climate, but I'm very fortunate to have Daniel here, who is an expert in this field. So Daniel, tell me, I've been here for about a week now, and it hasn't got dark once. It has been daytime, 24 hours a day, all day. Why does it never get dark in the Arctic?
Well, it does get dark in the Arctic, but it only gets dark once.
Right.
So it's really interesting. Here in the Arctic, we have 2 days in the year. We have the light day and the dark day.
Right.
Everywhere else in the world, you have this phenomenon of light and dark happening every single day.
Right.
But in the Arctic, it's happening once per year.
Right, okay.
And that's because the planet that we live on is not actually spinning like a spinning top.
Right.
It's spinning at an off axis, like so. And as it spins and goes around the sun, different parts of the planet are exposed to the light.
Right, okay.
So up here in the Arctic, it's lovely and light right now. It's the full polar day.
Right, okay.
Down in the Antarctic, it's the opposite. It's the polar night.
Oh, wow.
And that is lasting for half of the year.
Oh my goodness.
So right now we are in the midnight sun.
Yeah, that's right.
And down south in Antarctica right now, it's the midday dark.
Wow, what a phenomenon. So every single day right now, the sun doesn't stay, just stays light 24 hours a day.
That's right, yeah.
And when will it start to get dark?
So it's going to start getting dark. I mean, every day it's creeping towards nighttime.
Okay, right.
So a few days ago, the 21st of June, was the solstice, the longest day of the year.
Okay.
And every day after that, it's getting closer to the end of the day.
Oh.
So we're about 8 o'clock in the evening right now, in the polar day.
Wow, okay.
So a few more months, we'll get towards dark.
Basically the longest day in the world. We're looking at like a 6-month day.
Basically.
Right,
Exactly
okay.
right.
Yeah, I thought the day was going on very long.
It's a very, very long day.
Okay, amazing. So, okay, the second question is this. It is cold here. There's no question it's cold. It can get to -40. That's I jumped in the water today. It was freezing. Okay.
Definitively.
Why is it so cold here?
The temperature in the Arctic is a complex subject.
Okay.
So the first big thing is that our weather systems on this planet, everything comes from the sun.
Okay.
Okay, and it begins at the equator.
Okay.
And you get this warming air kind of rising off the equator. And as that warm air rises off the equator, it brings moisture to the atmosphere and it rises up and it hits our outer atmosphere. Okay, when it hits the outer atmosphere, it has to go somewhere, and so it goes north or it goes south.
Right.
And by the time it gets to the north, the very North Pole,
Yes.
okay, it's risen up to the atmosphere and it comes over the North Pole and it falls down on the planet, this dense air.
Okay.
Okay, and it's this deeply cold air because every time it goes up and down as it crosses the planet, it gets colder and drier and colder and drier.
Okay.
So that's the first answer.
Right,
You
okay.
have this cold air falling out of the atmosphere
Yes.
and landing on the pole.
I can feel it now. It's freezing. My hands are getting cold.
The other thing you could feel is how dry the air is.
It is dry, yes.
Yeah, and that's because all the way from the equator, every time it's come back down and risen back up again into the atmosphere, more moisture has been taken out of it.
Right.
So we're in the polar desert for that reason.
Yes, okay.
And the other reason it's so cold is that all this lovely white ice we have here surrounding us is reflecting all the sun's heat
Right.
back into the atmosphere.
Amazing.
So if we were surrounded by mud or dirt or grass or roads,
Yes.
that would absorb heat.
Yes, of course.
Okay, just like standing on a road after a hot day, the heat's coming from the ground. You can feel it under your
Yes.
feet. But here, standing on that clean white surface,
Yep.
it's reflecting heat, bouncing it back into the atmosphere. And so any heat that manages to get in here,
Yep.
it can't stay.
It's sent back out. Okay, so there's 3 reasons really. We've got this, this air moving up from the equator and slowly cooling on its way here.
and drying out.
And drying out. We've got this no moisture in the air, so it's very, very cool. And also the ice, which we'll come to in week 6, the ice is reflecting the sun's light and causing it to be cold.
It is. That's 2 or 3 out of about 100 different reasons.
Yeah, of course, and there are many more, and the children will research those in this learning sequence. But another question is, this area is cold, and is it important that it stays cold? What happens if this area becomes warmer? What happens if there is no ice? What happens if this area becomes, a warm desert rather than a polar desert?
Yeah, so I guess there's two answers here. And the first is that what happens if this area loses ice? It gets warm enough to lose ice. So the sea ice is a really important part of our world ecosystem. What happens is that when sea ice forms, the ice freezes the surface of the ocean, and it's lovely salty water in the ocean.
Yes.
And when it freezes, it kicks the salt out of the water. So all this frozen seawater is actually fresh ice. You could melt it and make a cup of tea.
Right.
Okay. The ice, but the salt had to go somewhere, and it fell into the water below.
Okay.
And every time that happens, that salt makes the water more dense.
Oh, yes.
Okay, more concentrated, heavier.
Yes.
And that water pushes down. Okay, and it's the pump that makes our ocean's currents move.
Right, okay.
Okay, it presses our ocean's currents. So every ocean current in the world begins in the Arctic or the Antarctic.
Okay, I see.
Now, if we had a warmer ocean that wasn't freezing,
Yes.
the pump stops.
Right, okay.
And it's I always say it's like two valves of your
I
heart.
was just going to say that.
You have there the Arctic and the Antarctic. And in our summer, the ice is slowly melting. Okay, in the Antarctic, it's freezing right now.
Of course.
And it's pressing down on the ocean.
Okay.
And then as winter arrives here, the polar night,
Yes.
it's going to press down.
Right.
And so you get these two valves to your heart. And if that changes,
That's right.
then we lose one of the valves of the heart.
And the pump that pushes this water around the earth and causes our climate and our weather and all of our wonderful biomes and ecosystems.
And the rain that makes the plants grow in your backyard.
That's right, okay.
It all changes.
So not only the fact that the ice is important because it reflects heat, and if we lose the ice, we lose that reflectivity. The second part is, which I think is very hard to understand and rare knowledge, this, that you have these two pumps, an Antarctic pump and an Arctic pump, and they pump the Earth's ocean currents around the planet. It's amazing.
So warming oceans here in the Arctic affect what happens in your backyard.
That's right.
All around the globe.
Amazing. All right, so we'll leave it there. Thank you, everybody. Now, what we're going to do this week is we're going to ask you to pick SDG number 13. And what you're going to do is you are going to make an action plan for your community. You're going to decide on 10 actions that your community can take. And don't forget, your children, you're going to drive this with your parents. You're going to talk to politicians. You're going to be making phone calls to local radio stations. We want your community to change the way that they live, all the small things, to take action and hopefully help this wonderful environment sustain the way it looks today, keeping it cool, pumping those ocean currents around the earth, and sustaining this wonderful reflective ice. So thank you so much, Daniel, for your
My pleasure, man.
wonderful wisdom. It's been amazing to have you.
Thank you.
Okay, thank you so much.